All right, ladies and gentlemen, let's look at our day 2 of our 5 Days to Greatness training evolution here. Today's work is on the topic of interfaces and abstraction. So you can read through all of this and do this code and make it real. So an interface is a programming construct which specifies that something must be done in the realizing class, that is the class to which the interface is applied to. Right, so we have an interface called vehicle and we're applying that to truck, boat, and car. And if I apply the interface, that means that the realizing or the concrete class, right, so truck in this case is a concrete class. It's a class that we actually work with in our code. The concrete class, which is receiving the interface, must deliver the promised functions. And they have to say override because they're overriding something they're inheriting from. This is new stuff. You haven't seen it before, but you're here in the elite training camp because you want to be a tier 1 operator. So you have to sort of get out there and hit it, work the training drills, and then it'll make sense. So interface specifies something must be done, but does not say how to do it. That is up to the programmer implementing the class. Why is this useful? Well, that's something I'm going to save for a class next week. We'll get into when we go back to our UML designs. We will see why giving this degree of freedom to the programmer allows software designs that are extremely flexible and extremely accommodating to the requirements of the business domain that we're modeling. Right, so interface is part 1 of today's work. The other thing now is abstract class. So an abstract class is partially implemented. It can contain both implemented members and members which have not been implemented yet, but which will be implemented in the realizing class. So an abstract class can have data with actual values and constructors. Any abstract method must be implemented by its subclasses or its concrete class. So interface and abstract have some similarities and they can work together. So you see here in this code example, we are applying both abstract and interface to some of our concrete classes. So rather than me talking about it a lot, you go through, retype this code, read these descriptions, and we will continue to build on this tomorrow.
The hum of computers, distant chatter, the clink of coffee cups. Every software project begins with optimism and a deadline. But as complexity grows, that optimism meets its first real test. Meet Taraneh, a project manager caught in the storm of a growing enterprise app, a system meant to connect hundreds of users, vendors, and deliveries in perfect synchronization. On this morning, her coffee is still warm, but her inbox is on fire. The client wants to accelerate delivery. 5 teams in parallel, each racing toward the same goal. What happens next isn't about coding speed. It's about architecture. Because in large systems, chaos doesn't come from bad programmers. It comes from lack of integration between project modules, when one team's change breaks another's foundation. So Taraneh gathers her crew, Misha, Ravi, Kim, and Lucas, and together they discover a powerful truth of software engineering. Good architecture is leadership. It's the language that keeps people aligned when everything moves fast. Watch now. As we enter Taraneh's office in medias res, the moment when caffeine meets crisis, and abstraction becomes the bridge between chaos and control. Cue fade to screenshot, the high cost of tight coupling, a project manager's day journal.